Hello again. Let's get started. So scrolling down and on the next page, well, my stuff is a little far down here. Let's look at this problem here. D by dx of 1 over the square root of 4x minus 3. That's d by dx of 4x minus 3 to the negative half power by the definition of the negative half power. Now this naturally is going to call on the chain rule. We let u equal the 4x minus 3, so I do d by du of, and we're raising u to the negative half power, times d by dx of the u term, right here, as usual. Now, again, d by du of u to the the neg half comes down, and we subtract 1 off neg half and get neg 3 halves. So we have the u term to the negative 3 halves. Now, if this other guy, the derivative of the u term right here, the derivative of 4x minus 3 is just 4 itself. The negative 3 gets killed, and the 4x gets derivated. When you derivate 4x, you get 4. And I need to, that's bad spacing. Let me respace this. Nothing is incorrect, it's just my spacing is bad. So let me do that, and it's being badly behaved. Maybe it'll behave in a minute. So there's that, and it, but anyway, it's not letting me do my font. Sorry about that, guys. Sorry about the pause and the silence there. There we go. So there's that. Okay, so we've got, so there's that 4. Now guys, that negative 1 half and that 4 are going to multiply together and give you negative 2. And so you're going to get negative 2 times the 4x minus 3 to the negative half power. And then, now, this is understood to be, well, the negative 2 comes on top. Now, I went ahead, you can just, if you'd rather, you can take this negative and put it out to the side. I just put it up here. You could go either way. So I got negative 2 over. Now, yeah, I'd have 4x minus 3 to the positive 3 halves down here, but I'll go ahead and cut to the chase. What is 4x minus 3 to the 3 halves power? It's 4x minus 3 to the 1 power right here times 4x minus 3 to the 1 half power here. So what's going on is what this guy right here is 4x minus 3 to the positive 3 halves power, but I go ahead and write it in the radical form, and I simplified it that, in simplified radical form at that. Now that's all well and good, but now what I do is I stick a radical 4x minus 3 up here, and I stick another one down here to go beside this one. And what's going to happen is the new guy that I stick down here is going to run into this guy and just give you a plain 4x minus 3. Now the one that's up here just stays put. And so this is by algebra 2. So what I get is I get negative 2 times radical over, now if you multiply somebody by himself, that's just somebody squared. So 4x minus 3 times himself is just 4x minus 3 squared. You'll need the parenthesis because you're squaring the whole thing. But otherwise that's it. And again, what I did was I stuck a radical up here. I multiplied negative 2 times the square root of 4x minus 3. And I put another, that allows me to put another square root of 4x minus 3 down here to go with this one that's already down here. But if you have radical 4x minus 3 times himself by associativity, you can multiply this radical times this radical and get this guy. If that bothers you, let me put that in. I know you may be a visual person, which is fine. That's good. So I'll accommodate for that. And let me just do some copying and pasting. That can be dangerous, but I'll try to make it work. It just saves me from having to type, so excuse the silence. So what I'm going to do is I'm going to paste this right here. And if it will let me, I'm going to paste it right here. Yes! Okay, good. So I stuck another radical 4x minus 3 beside this one. Now guys, by associativity, we can go ahead and multiply this radical times this radical and just get plain Jane 4x minus 3. And that's what we're after. The moral of the story is I don't want any radicals on my denominator. That's what I'm getting at, okay? But anyhow, there's that. And then we're done. And again, as always, the whole time u equals 4x minus 3. That's been true from the get-go. But anyway, so there's that. And I'll leave it for you to do this guy right here. All right. Again, I'm just wanting to show off the chain rule. We derivate u with we derivate this function of u with respect to u, and now here we derivate the u term itself with respect to x. But now we don't put u here. We write 4x minus 3, Yeah, it's true, u equals 4x minus 3, but I want to actually put 4x minus 3 in here. Yeah, this is du by dx, so to speak, but that would be a messy way to put it. I'd like to put it like this. Okay. But anyhow, moving along. Now, guys, recall that d by dx of e to the x is e to the x. That's the prettiest derivative of all, in my opinion. Now, what if we mess things up a little bit? What if we don't have e to the x? Recall in general, it would have been good if I went down here and kind of did this guy first. Let's look at this guy. D by dx of e to any function f of x, assuming f is differentiable. You know, we're assuming f can be derivated. That's not true of all functions, but assume that f is a function that can be. So that's going to be d by du of e to the u times d by dx of f of x. This is by the chain rule, guys. And u equals f of x. So I'm doing d by du of eu times d by dx of my f of x. Again, my u term is f of x. Now, hey, that's nice. D by du of eu is just e to the u. Now, d by dx of fx, let's just call that f prime. You know, you could leave it like this. Now, do be careful with f prime. That can get you in trouble sometimes. If it just, but here, it's pretty obvious what we're talking about. So that's equal to, now you got to replace u back with f of x. So it's e to the f of x. I'm just replacing this u back with f of x here. E to the f of x times f prime of x, where u equals f of x. Now, some professors are real funny about f prime of x. I knew one professor who was notoriously picky about it. He was fine with it, but he demanded that you specify, exactly where it comes from. And you probably should do that. It is good manners, I'll admit. You do need to specify f prime is d by dx of f of x. Later on, f prime could be ambiguous. Here it's pretty obvious we're derivating with respect to x, but later on that may become less obvious. But do specify, use good manners, and put this down here. And I forgot to do it myself until now. So just be sure to do that, and you'll have it made. It's just nicer to put f prime instead of having to each time either write or type d by dx of f of x each and every time. F prime, it's just a lazy man's notation. And now let's go back up here. Again, now what if we use a concrete f of x, like f of x equals x squared? So d by dx of e to the x squared, that's d by du. We're going to replace x squared by u, by the way. So it's d by du of e to the u times d by dx of x squared. Again, x squared is my u term. So now d by du of e to the u is e to the u. D by dx of x squared is 2x. So it's just 2x e to the u. But hey, let's just go ahead and cut to the chase. U is x squared, so just put that back in. So e to the x squared times 2x by commutativity is just back up. E to the x squared times 2x is 2x e to the x squared by commutativity. Got tongue-tied there. So there's that. So the derivative of this guy with respect to x is this guy right here. Okay. And so there's that. And you can see the chain rule is greatly useful, right? It's a powerful tool to have in our machinery. Now, d by dx of e to the sine x, that's d by du of e to the u times d by dx of sine x, where my u term is the sine x. Now, again, we get e to the u times, remember the derivative of the sine is the cosine, and then just replace u with the sine, and so it's e to the sine times the cosine, and we're done. And I'm really being sloppy. When I say sine, I mean sine of x, and when I say cosine, I mean cosine of x, but you get the idea. Okay. Now, and I'll leave it for you to do this guy down here. And let's see, let me scroll down. It's been a little difficult. Come on. Let's say I've got this guy right here. If I let u equal f of x, and if I do d by dx of the sine of f of x, well, by the chain rule, u equals f of x, so I do d by du of the sine of u times d by dx of f of x. And now d by du of the sine of u is the cosine of u. D by dx of f of x is f prime of x. So I just get the cosine of f of x times f prime of x. You got to go back in this guy and replace u with f of x. Otherwise, that's it. And guys, I'll stop the video Thank you. I'll see you on the next video.